Hello, my name is Parham Mohammadi. My student ID is W2046966. Today, I'm gonna present my IPD for RAGBot, no-code AI chatbot platform using retrieval augment generation or RAG, which was supervised by Mr. Cosmos or Cosmopoulos. Today, I'll cover stakeholder analysis, requirements and implementation status, 5 detailed use cases, system architecture, RAG pipeline implementation, timeline and progress, testing results, and challenge and future works. Here, I've used Onion model to organize 12 stakeholders across 4 layers using Onion diagram. At the core, you can see myself and my supervisor, which we had daily involvement in the project. Then you can see primary users. Primary users are direct users, such as small business owners, e-commerce owners, educational administrators, healthcare providers, and these are the people who use my platform mostly. Then we have technical stakeholders. You can see OpenAI as an API provider, which we use GPT-4 and embeddings and the open source community. And then we can see external stakeholders as well, such as University of Westminster, end users of customer of business, and competing platforms. On the other hand, we have the power interest matrix, and it shows power and or interest of different stakeholders and how much effect and how much impact they have. Now, here I've organized my requirements using Moscow table, and I'm going to present different functional requirements and after the non-functional requirements of my project. The first one was user account management, which included JWT authentication, password reset, profile management, which was fully implemented and tested with 15 different datasets. Then we have functional requirement 2, document upload and processing, which included 4 different types: PDF, docx, TXT, and Word document, up to 10 megabytes with automatic text extraction, chunking, and embedding. This was fully implemented as well. Processed 150 pages during like 50 to 60 seconds. Then functional requirement 3, chatbot creation and configuration. The creation is there, it's implemented, but configuration is not. So basically, it's a basic stuff to configure the chatbot. The purpose of the IPD was just try to implement the RAG, then get to the customization point. For requirement 5, chatbot testing and deployment. So a web-based playground. This was implemented as well for testing the chatbot before implementing it on your website. And then we have non-functional requirements. So these are about performance and different matrices. So the first one is performance. I was expecting under 3-second average response, and my average response was 2.3. Then the scalability. So basically, this is not tested yet. It's going to be tested after IPD. And then we have the security. And the security is there. I'm going to use HTTPS encryption for the connection between frontend and backend, and JWT token and password hashing, which is included in the Django system, is there. So that's implemented as well. Then it's the usability. So basically, a non-technical user can use it. That's it's partial implemented. So basically, now you're able to create the chatbot, but you need to get the embedded code to implement it to your website. That's going to be for after IPD. So overall, and accuracy, the last but not the least, the accuracy, I was aiming for more than 85% accuracy. During my test, I reached 81% accuracy in responses. So I think I'm on the right track because the retrieved chunks, they can answer the customers grounded to the uploaded document. And overall, my status is like 10 out of 12 requirements are implemented. Some of them are partial, some of them are fully. I'm 80% done with required implementation, but I've got some optional options that I would consider if I have them. Here we can see I have use case diagram, which has 2 main actors. So the first one is business owner who register, upload the documents, and then make the chatbot, manage the chatbot, test it, and deploy it. And I can check the analysis. And we have the end user who only asks questions and get response based on the documents uploaded. Then here I've developed some use cases. So first one is Sarah. She has a 30-seat restaurant. She gets 50 weekly repetitive queries. So she wants to make a chatbot about menu items, allergen information, opening hours. She doesn't have any skill, but her goal is to have 24/7 customer service with no extra stuff. So what she have to do, she's going to enter our website, she's going to create an account, she's going to create a chatbot, upload these documents, and configure the chatbot and implement it. Here we can see in the playground, I'll ask some questions based on some related information, and you can see that if it's not about if the information is not included in the document, it's gonna reject to answer it and says politely says I don't know. But if we have it in documents, it would explain it. Same here, we have Dr. Smith, department administrator, 200 students, multiple modules, some basic questions about like what is the PPRS deadline, how is the FIB weighted, can I get reference for my university application maybe. So what he's gonna do, he's gonna upload some documents and then create the chatbot, process it, and give it some information and see how it works. We can see here if we have the information, it would answer, and if it doesn't, it doesn't. The third use case, we have e-commerce. We have Jake, so James, he works at OnRunning. These are some sustainability reports. Some people might be interested about it, like how much CO2 this company produces during different years. So they can ask this chatbot, and it would answer if they have the information. Then the last, not the last one actually, we have a healthcare administrator using it to answer a typical question about opening hour, what are the clinic policies, what clinic provides. So here you can see it's a bit more, during these use cases, you can see the different structure in the responses from the bot. That's because in the configuration, I created different, I gave it different prompts. So the last use case is actually not implemented yet. This is about a university student who might want to use this as opportunity to learn RAG implementation and how to implement it. As you can see, 67% of developers struggle, as I've noticed during my PPRS. So I'm gonna do a full RAG implementation on GitHub. I'm gonna have a full report on it and some diagrams. Here we can see the architecture of our system. It's a 5-layer architecture. First, we have the client layer. So we have React, which is our front end on port 3000 on my local PC for now. Then we have embeddable widgets, which are not implemented yet. Then HTTPS, which is our secure way between front end and back end. And we have the application layer, which has different API endpoints, authentication, chatbot endpoints, query endpoints, and documents, analytics, and embedded codes. Then we have the business logic layer, which has RAG processing pipeline. We have text extraction, then chunk it, and then embed it and store it in our vector storage. Then we have our integration layer, which is LangChain framework and OpenAI API, GPT-4 and GPT 3.5, plus ADO and -002 as my embedding system. And the last one is data layer using Postgres 15 on the port 5432, which is for now is on my local system. Then I have the user table, bots table, and document table, chunks vector for the documents, analytic table, and message table. Here you can see the database center, which at the center we have the chat base. A user can have many chat base. A chat base can have many documents. A document can have many chunks. And also a chatbot user has connection can check different analysis for different chatbots. Chatbots can have different messages. So it's one-to-many connections. And here we can see the RAG pipeline flow. So it has 9 stages, which is divided to 2 processes. First is document processing, then query processing. First, I'm going to explain document processing. User uploads the document would to the front end. The document would be sent to backend. The text would be extracted using text extractor. Then it would be sent back to the backend. Then the text would be turned into chunks using LangChain. And again, we get the list of chunks back to the backend. The embeddings would be generated using OpenAI ADO 002. Then the vector embeddings would be sent back to the backend. Then the vectors would be saved in the database, which is PostgreSQL or PG vector. And the success message would be sent to the backend, and backend would send it to front, and front would show it to the user. The next page we have is RAG pipeline query processing. So here you can see the end user asks a question, it would be sent to the backend. Backend would generate the query, so it would embed it. And then the query would be sent back to the backend. Backend would try to search for similarity between this and the context that was uploaded before by the main user. And then top 3 or top 5 relevant chunks would be extracted from the text. And we're going to assemble the prompt with the context that we retrieved from our database. And the ChatGPT would generate some response. The AI response would be sent back to the front end and front end to the customer. This takes about 2.3 seconds, as you can see. So next, here we have a RAG algorithm. How does it work? So first, the main one is the cosine similarity. Basically, this decides how much is the similarity between query that a user asked and the document chunks that was uploaded before. Using this formula, for example, we have a threshold. It will generate a number between 0 to 1. And so we have a threshold, for example, if it's over 0.7, we're going to count it as similar. So here you can see an example. Gluten-free options. We offer gluten-free pasta, 89% similarity. Our restaurant is in London, low similarity. So it's going to decide chunk one. So here you can see it in the diagram. The user query, it's going to ask a question. It's going to make embedding, same embedded method as the uploaded documents. Then we're going to calculate the similarity with all chunks. These are the similarity percent from 0 to 1, type 5 retrieved. And we're going to send it to GPT and give the query, base query as well, and get the response. Here you can see the document chunking algorithm. We have the code here. So basically, we get the maximum token, which is 1,000, and overlap with 10%. So this means in each chunk, for example, it's going to end with, let's see, here we have an example. Free pasta, our menu becomes 2 chunks, but our menu appears at the end of chunk 1 and the start of chunk 2. So basically, all of the chunks are going to have complete sentences or try to be more complete and have the whole context using this algorithm. Then we have the embedding generation. So first, we're going to input the text for documents. We have a limit of 8,191 tokens, and the output would be this or 1,536. This is how we store our data in our database. And we're going to tokenize the text using tick token. Basically, it's a library, and then call for OpenAI API for ADO002 to embed the text and return to vector. This is going to be the mathematical representation of our data. For example, gluten-free pasta would represent like this. And our performance, so the price is really low. You can see 1K token. It's going to cost us this much. And we have 200 milliseconds per chunk. Uploading time and embedding time. And on the other hand, we have the semantic search, as I explained. It works based on the threshold. And a user can decide that threshold. Basically, if you have a document that is generic or you want the AI to be more creative, you can lower the threshold. But if you want to be strict and the AI be 100% sure that that content exists in your uploaded document, so you're gonna higher the threshold. And here we have the PostgreSQL implementation. So basically, this is how I implemented my query vector in Postgres instead of Pinnacle. So here you can see the time complexity of this, which is a log. It would increase. So, but compared to other complexity, this is really good. And the performance for 10,000 chunks was under 100 milliseconds as I tested. And here you can see the technology stack. For backend, I chose Python 3.12, the Django 5, and because it had JWT, and I use simple JWT. For database, PostgreSQL 15, and for document database, I use PG Vector. For the infrastructure, I'm gonna use Docker for when I plan to deploy the project on the server. But now I'm using GitHub for documenting my process and my progress. For the front end, you can see I use React 18, which has Material UI for easy design, Access, which makes API endpoints and HTTP safe passages. And for AI or ML, I used GPT 3.5 Turbo for now as a testing, which cost about 2 cents for 1,000 tokens. And ADO002 for embedding, LangChain for document chunking, and 1536 dimensional vectors for saving the documents. So I had three critical decisions. First one was about my database. I extended it to use PG Vector instead of Pinnacle to save some money because Pinnacle was a paid subscription. It took me 2 more days, but at least I didn't have to pay. And I used Django, built-in admin, ORM, and security. So basically, what was different from PPRS, I changed my model and changed it to GPT 3.5 Turbo because it was cheaper. It's for now. Originally, I planned to use GPT-4, but I changed it to this for the cost. Here you can see my timeline. The green ones are the ones that I've done. PPRS feedback analysis, environment setup, backend authentication using JWT, database setup, document uploaded process, RAG pipeline, testing, and these were done. But what remained to be done is the front-end chat UI implementation, which is planned to be done in this month, and the IDP demonstration, which is today that I'm doing it. And we have some extra plans for after IPD submission that I would do after I got my feedback. Here we have some timeline changes. We have four main changes. So the first one is Pinnacle to PG Vector, as I mentioned. It took me 2 more days, but it saved me £17 a month. Second one was I extended the testing from 60 tests to 240 tests. This helped me to increase the accuracy and get a better testing result. And overall, I exceeded my plan for PPRS for 10 days, but I think I'm on the right track, so it's okay. But these decisions demonstrated my ability to adapt myself to the situation. For testing the project, I had three different type of tests. First was the interim quantitative evaluation, which basically it was a manual test. I created four chatbots. We had maybe 30 to 40 messages. Here stated 28, about 28 messages. Average token for each response was 644 token. The range was from 141 to 1141 for each message. And average retrieved source, relevant retrieved source was 3 to 4. The max source retrieved was 5. Retrieval varies by query. So out of scope handling was correct. So it rejected all of the questions out of the document, and the price was about in this range based on the published price on OpenAI website. Here we can see the manual testing we had. So for the manual testing, we had 240 total queries. 195 was true, was good queries. So we had 81% in accuracy. The target for PPRS was 85%. I'm now on the right track for that by tuning the chunk sizes, retrieval depth, and prompt refinement and prompt engineering. And then we have the use cases. I've tested these queries on them. And on next, we have the comprehensive testing results. These are the automated test results, which was taken by using PyTest and different systems. I've achieved 98%, which was about 67 passes in 68 tests. You can see the test here. We have 15 authentication tests, such as creating the account, then uploading the document, RAG pipeline tests, safety tests, boundary tests, performance tests, and UI front-end tests. And you can see here the performance benchmark. The average response time was 2.3, which exceeded the 3 seconds expectation for PPRS. The 95 percentile was 2.73, which exceeded again the 3 second expectation. The vector search took less than 100 milliseconds. This is fast. Next, we're gonna go to key challenges I faced and the solutions I've had. The first challenge was the hallucination. So basically, on the initial test, AI showed inventing information. So basically, if you ask where is the capital of France, it would say Paris, even though the chat wasn't about that. It was about the restaurant. So it should refuse if they are uncertain. So I noticed the prompt engineering is important in this matter, that you control the bot. If they don't know, they're gonna say, I don't know. They wouldn't generate information or be creative. But this depends on you and how you set your bot. The second one was the initial response time was about 5 to 7 seconds, and this was long. So I tried to optimize the chunking strategy. I played with how much token each chunk should be. So I've tried to optimize that using my lessons in optimization. And the third challenge was document processing speed. I've learned that when you're uploading the document, there are different types of uploading and where you upload it. So this would take time. And I've learned that large PDF cause timeout, and I try to fix them with streaming text extraction, parallel chunk processing, and this type of stuff. And for a fourth challenge, the accuracy on complex queries. So basically, we had complex queries or different type of queries which needed more information and more context from different parts of documents. So if we had the question was a multi-part question, so we need multiple places to get reference from. Then we have the remaining work for February and April. On the late March, we need to do the embed code generator API, copy and paste widget interface, and iframe responsive design. Then the test on the sample website. So I need to deploy it on the website. For late March, early April, I need to write my documentation, my README documentation, and create a user guide and documentation on my endpoints. For early April, which is I'm going to create the final report, finalize the front end, finalize the back end, and be ready to complete the report based on completed project and submit the deliverables for final year project. But what are the current limitations? So basically, the first limitation is the accuracy. I need to improve my accuracy to 85% by improving my prompt engineering and better semantic and chunking and query reformulation techniques. I need to reformulate my queries when they are being asked for example, when there is not or doesn't in the question. For example, dish does not contain gluten, and the bot starts to fail or be confused. And we have the scope limitation. We don't have access to mobile app. It's not going to be on mobile app. It's going to support multi-language. It's not going to have voice interface, no payment integration. But we still plan this for our future to improve our accuracy to 80+%, have hybrid search, and add more document format support, such as Excel, PowerPoint, maybe URL, maybe images, and implement caching for common queries. So basically, if a specific business owner knows that this question is going to be asked a lot, so they can provide the basic answer beforehand, so the bot is ready and knows the answer. They don't need to spend that much token. An optional extension I plan to explore is having multiple models. So basically, the user can choose between them for the plus and paid version. So they can choose between different models and deploy them. For example, I have two LLMs from OpenAI, Claude, Gemini, but if I have time. And the key learnings from this project was first, on one hand, we have the technical skills such as RAG implementation, its architecture, how does it work, and working with the vector database and implementing it using PG vector, how to prompt engineer LLM to get better accuracy, the full stack development. I had experience, but this one was different because I had more APIs, and I used automated testing frameworks, as I said, such as PyTest or Selenium, and the API designs and integration for OpenAI APIs. I had a problem-solving experience. First was a hallucination prevention. I learned the system for prompts, and for performance optimization, I learned how to chunk the data and how to play with different parameters to get better accuracy, better results throughout the test. At the same time, for all of this, I improvised the testing plan, automatic testing plan using LLMs to create me a code that can overview my system when I'm working with it. When I'm doing my manual test, it takes time. It takes time measurements and store them, and then I would turn them to tables, as you saw. And project management insight started with a clear requirement PPRS, but now I have a better vision on it. The Gantt chart helped me to have better planning, and I've updated throughout the process. I prioritize the core elements because first I need to build a foundation, then I can design it. Regular testing revealed the issue during the process, so I didn't leave it out to the last day. And documentation, at the same time I was doing the work, I was documenting the process. So now I know everything. But what I would do differently, I would start performance optimization earlier, so optimize the system more throughout the way. Build automated tests from day one, so test everything one by one, piece by piece. No small component, not all the system at once. Test with real documents sooner. I uploaded real business documents at some point, but not at the first stage. I was using fake documents or generic documents. And I would overall spend more time on tuning the model to get better accuracy. Overall, thank you. This was my IPD presentation. This is my GitHub link. You can have access to my prototype through this link. Thank you for listening.